Bentley Water is designed for registering, maintaining, and analyzing information associated with a water supply network. By using the mapping, power, and database structure available with MicroStation Geographics, Bentley Water can maintain an accurate model of the water supply network that takes advantage of both a digital map and a highly structured database. In this particular example, I've already used the tools of Geographics to attach an underlying CAD map, which is of cadastral information of the parcels, as well as a water network. In addition, if we were to select on any one of these features, because we're using a Geographics feature model, I can see that that happens to be a particular pipe supply feature, and it's connected between node 82 and node 74. If we zoom down here to the lower left, let's quickly look at some of the placement tools in Bentley Water. If, for instance, I wanted to place a node, which could be something like a pipe end or a manhole, one of the advantages of Bentley Water is it'll automatically feature code it and attribute it at the same time. And you can see that we have a number of pull-down menus in which we can set up what type of node that is, the state of that node, the location. And the nice thing about this is that all of these dialogues here can be very easily customized through a simple ASCII text file. So if I wanted to add my own list of pipe types here, my own list of states, I could do it very easily through a text file, and then we simply reload the application. So let's start by placing a couple of nodes, and what I might first do is select on a node which I want to inherit those attributes from. So here we can see it automatically places the elevation. If I were to bump that up, let's say we're going downstream here, as I adjust the height, it'll automatically adjust the invert elevation, you'll see here, because the depth of that pipe is, in this case, 1 meter. So now I could go ahead and I could place that node, and we can have it automatically increment the node number. And then I can once again bump the elevation up, so now to 670. You'll see it'll change that bottom elevation as well. So I've gone in, I've quickly placed a couple of nodes, and we've attributed those at the same time. Now if we just zoom in a little bit closer, next thing I want to do is place a pipe. As I place those pipes, it once again, the rules built into the system force me to attach those two nodes. So I can't just place a pipe anywhere in the system because we've got a closed network here. So as I select on a pipe, it'll tell me it's that particular pipe. You can see it up here in the dialog box and the elevation of that pipe. I can accept that. At this point, I can place as many data points as I want, or I can simply reset and select my end node. When I select on that end node, you can see it tells me it's going from this node E18 to N9. It's got the length there in the working units, in this case 37 meters. I can accept that now, and it will place that pipe. And you'll see it'll automatically go at this stage and attribute it as well. Now when placing the pipe, if I wanted to inherit from an existing pipe, I could simply select on this pipe, and you'll notice over here when I accept it, it'll update all of the attributes to reflect that I'm using a 250 millimeter supply pipe. So now I can select on that one, accept it, reset, once again move down to my next node, and it'll automatically place that, attribute it as I placed it. Now, if we wanted to customize the look and feel of what we are seeing here, we could go in and I could say go into the setup parameters, and maybe actually when I'm looking at the annotation, I don't actually want to see pipe dimension and material and length. Maybe all I want to see is just the pipe dimension and the material. And so I'll get rid of my little separator here, and I'll save that. And now if we go ahead and we update the view, we can see that the attributes here are database driven, so that the graphics are generated on the fly from the information in the database. The same is true if I were to go now and move a particular node. So if I were to select on this particular node here, and we moved it off out several meters closer to the center line of the road, and then I went to update the view, it's going to update those pipes to reflect the fact that that node has moved. Now, so not only do we have intelligent information in terms of placing the line work as well as the graphics, but of course the fact that it's all database driven is important. Now, if I wanted to run a trace, because everything here is connected, I could say let's do a connection trace, and I'm going to start down here in the lower left corner, and I want to start from this last node or manhole that I placed. If I run that trace, you can see it goes up to a particular point where it stops. If I wanted to open up a second window here now, which is in this particular area where the trace has stopped, in fact it stopped right at this valve. If I just want to quickly have a look now at that particular valve, the attributes of it, I can select on it, and I can see in fact that it is in the closed position. So if now I go and I open that valve, and we save that in the database, and we run our trace once again, it should now go through that particular valve. So let's just turn that one off, and that was a connection trace. We'll run it once again, and we'll run it from the same point. And now if you keep your eye on that second window, it'll now go right through that valve, as that valve is now in the open position.